Okay, so today we're going to start looking at transition matrices. So transition matrix is it's a square, always a square matrix. And what it does is it's a matrix that they use or they've created to predict of something that would happen in the future. So, and they created it using like statistics or things that have happened earlier on. So say take for example over here, this is an example of a transition matrix, and you'll see they'll use the letter T to represent the transition matrix. And so what it'll show, so here they were looking at the weather and whether the day, whether it rained or whether it remained dry. So, and they've done all this and they've worked out, say this is probably like looking at the probability of it being, whether it's going to be dry or whether it's going to rain. So what happens is you can see here, you'll have, so it'll be a square and you'll have what's going to happen. So if you have a look here, if they say, often they'll say, this is now, and then this was what will happen in the next thing. So if you look here, if we said it says 0.7 on rain now and rain the next day. So what that means is there's 70% chance that it's going to rain on the next day. Okay? And then if you look, what's the chance that if it's dry, it'll be dry the next day? If you have a look, yeah, good, it's 50%. Okay, so this is what a transition does. So then what we do, and we'll look into it, we'll give you what we call a state matrix. And a state matrix is what's actually happening. So what they said on the first day, and they'll call it SO, meaning the original day. On the original day, it rained, and that's why there's a 1 and a 0. Now, if I use the transition matrix and I times it with the state matrix, so you can see there, if you have a transition, and this transition is a 2 by 2, and then you're going to multiply it with a state matrix and say the beginning one, which is a 2 by 1, you can see your answer would end up being a 2 by 1. And what it ends up being is the next state. So if I know on the day 0, it rained and then it was dry, then I go and I times that state by the transition matrix, and you'll get an answer. And then what you'll see is you'll see the probability that it'll rain on that next day or the probability that it'll be dry on the next day. So this is what we're going to be looking at. So at the moment, this first lesson is just looking at setting up a transition matrix and looking into that. Now, if you have a look, you'll notice that the transition matrix, they always have a decimal, and obviously they're going to add up to 1, the columns. So you know that's a fact you need to know because it might help you with just working out a transition. So here we go. So when we're setting up a transition matrix, the transition matrix is used to describe the transitions from one state to the other. So depending what you're looking at, say with the weather then, the state was a day. Every day was, you're moving to a next day, that's saying moving to the next state. Sometimes you might be looking at something like, we might be looking at weekly, sales in a shop. So then the state is a week, every week, and we'll get more into that. But let's have a look. So as I said, the transition will be denoted, meaning they'll use the letter T to represent the transition. And you'll see that we go from and to. So when I said, or like now and next. So that's how you set it up. Now, so percentages will always turned into decimals. So you need to be really careful. Just be careful. This is a common error. When it's 2%, it'd be 0.02 in your transition. So if you looked at that, if we looked at that state matrix, transition matrix they did before, we said the columns had to add up to 1, and you can see, we said that was rain and that was dry, and you can see that added up to 1. And then the other ones were 0.5 and 0.5. okay, and that added up to 1 as well. So we can see that. So let's have a look. So let's have a look at this one. So here we've got, this was a car rental place, okay? So they've got 2 branches. They've got 1 branch at Bendigo and 1 branch at Colac. And so what they said, we can see here they've done a network diagram of the transitioning. So what we can see, if the car was hired at Bendigo, 20% of them are returned to the Colac campus or venue. And if you say for example, if you rented it at Colac, it's a 90% chance that it'll go back to Colac. 90% of them go back to the same place. What about if you're at Bendigo? How many return to the Bendigo?
80.
Yeah, 80%. So this is how that can draw a diagram of the situation, or they can list it out like they have here. They've told you that information, but in words. So what we want to do is we want to be able to create a transition matrix from this. So remember, we're going to call it a T, transition matrix. And remember, it's always going to be square. So how many points you have is how many rows and columns you're going to have. So because this is a Bendigo and Colac, that's just 2. This one's going to be a 2 by 2. So what you're going to do is you'll have, and I'll just use B for Bendigo and C for Colac. Now, be careful, because I said Bendigo first, Colac second, when I go down the other side, that has to be in the same order. So remember, this is, we might say from and to there. So when you're working these out, often it's easy to do the ones that go back to itself because it's pretty clear, you can see an arrow. So for example, I'm going to go the Bendigo back to Bendigo is going to be in this spot, yeah? Now remember, we don't write percentages, we need it as a decimal. So 80% is going to be 0.8. Now, because I know these have to add up to 1, I know automatically that Bendigo to Colac should be 0.2. So let's just check that. So we're saying if we're at Bendigo and we go to Colac, yes it is. See how it was 20%? It's 0.2. Now, if we look at Colac to Colac, so that's often when I said those ones are easy, I can see down here that it's 0.9, and then I know because they have to add up to 1, that would be 10% there, but it's also indicated on the diagram. So there's that there. Okay, so let's do another example. So this one, the diagram gives the weekly return rates of rental cars at 3 locations. So now we've got 3, an Albury, Wodonga and Benalla. And it says construct a transition matrix. So we're going to construct the T matrix. Now, because we have 3 places, we're going to have that. So I'm going to say Albury, Wodonga and Benalla. Now, because I went that way, I have to say the same way down the other way. Okay? And we're going to say, from here to there. So, as I said, the ones that are to themselves are a lot easier, so I'm going to do them first. So I can see Albury to Albury is 0.7. And then the leading diagonal will be the ones going back to themselves. So the W to W was 80% and the B to B was 0.77. All right, so let's go finish the other ones. So if I'm at Albury and I'm going to go to Wodonga, so I'm looking for that arrow, I can see that that's 10%. So I'm going to write 0.Albury to Wodonga is 10%. So because I'm already at 0.8, what should the one Albury to Benalla should add up to? 0.2. So let's go just double check that. So I'll highlight that in green. So from Albury to Benalla, so I'm looking for that. Can you see? It was 20%. So you know you've done that right. Okay, let's fill in the rest of it. So I've got Wodonga, starting at Wodonga and going to A is 5%. Sorry, 0.05. So that means I'm up to 0.85. So what would this bottom one have to be? 1, yeah, because it's got to add up to 1. So double check that. Wodonga from W to B. Does it say 15%? Yep, it does. Okay, so now I've got to fill in the rest. Benalla, B to A, and B to A was 12%, so 0.12. So then I'm already up to, what's that, 0.89, so I should have 11% from B to W. And is that correct? Yes. Okay, a factory has a large number of machines. Machines can be in 2 states, either operating or broken. Broken machines are repaired and come back into operation or vice versa on a given day. So 85% of the machines that are operating stay operating. And then they're giving you all these data here. And so then it says construct a transition matrix. Use columns to define the situation at the start of the day and rows to describe the end. All that's saying is that, like what we've been doing, so we're going to set up a transition matrix and we're going to have either your operating or broken, okay? So operating and broken. And how I say, you know, this is start and this is, say, the end of the day. Like that. They're just saying to do it like that. So if you look up here, this first little thing, it said 85% of the machines that are operating stay operating. So O to O is 0.85. So, and then it said 15% that are operating break down, and that's good because I can see that adds up to 1. Okay? You don't have to put that arrow that it equals 1. I'm just showing you that. You just need to put the transition matrix. Okay, so it says 5% of the machines that are broken are repaired and start operating. So this was 5%. So remember, it's 0.05. And then 95% that are broken remain broken. So there's a transition.